Okay, exponential parent function. We said that we have the standard equation. I'm going to go quick because I'm just going to get right into the examples. We'll do enough examples to make sure you know how to do the homework tonight. And the homework's just going to be a couple of graphs this weekend. It's not going to be anything crazy. Okay, exponential parent function is when you have f of x equals a times b to the x. Right now, what is a going to be in every one of our problems? 1. So you're not even going to have to worry about that. This b is going to be how it grows. If b is bigger than 1, we're going to call it exponential growth or increasing. And that's going to form a certain kind of curve, which I'm going to show you in just a second. If b is less than 1, it's going to be exponential decay, which is a decrease. And you are going to have to write that if it's an increase or a decrease or growth or decay. Asymptote, we'll talk about this. This is new. We said it's the idea that you can get closer to something but never what? Touch, never get there. All right, this is where we left off. We had just gotten started. And we gotten to this point where we were plugging into 2 to the x. Okay? We said a was the y-intercept. We know it's going to cross at 0, 1. So we already have that point on the graph. Okay? And then we've got b to the x power, how it grows. If b is greater than 1, it's going to grow. If b is less than 1, it's going to be decay. So let's look at b. What is b in this problem? 2. So is b greater than 1?
Yeah.
Yeah, b equals 2. So what would this be? Growth or decay?
Growth.
This is a growth problem. Write that down. This is a growth problem because the base is bigger than 1. Now, I said what we need to do is figure out what this looks like. We know it's growth, but what does that mean? Is it a line? Is it a parabola? Okay, it's going to go up somehow, but how does that look? I actually call it, I have a special name for it. I call it the J-curve. So here's what's going to happen. When we plugged in 0 yesterday, what was anything to the 0 power? 1. 2 to the first power was 2. 2 to the second power is 4. 2 to the third power is 8. And what's happening? It's getting doubled. Okay? And see, when you understood exponential growth yesterday, William right away would have said, oh, if he's going to double a penny, I'm definitely doing the penny every time. There was a guy back in the they're dead. And the king of a country came to Archimedes and said, will you please figure out how to figure out the weight of this gold bar? And he needed to figure out density. And he was struggling with the problem. He says, here's the deal. If I figure this out for you, you got to pay me. And the king says, I'll pay you anything you want. And he says, I want you to give me 1 grain of rice. Because he was in China when this king asked him, give me 1 grain of rice. China was the most important thing to the Chinese. 1 grain of rice for every square on a checkered board. But every square, on the first square, you give 1 grain of rice. On the second square, you give 2 grains of rice. On the third square, 4 grains of rice, and he kept doubling it. He says, I want you to double it every time a square. How many squares are on a checkerboard? 64. 64 squares. Take your calculator out and go 2 to the 64th power. 2 caret key 64. It's too big of a number. It says 1 point something, and at the very end it says E19. Do you know what that means, that E19 means? That means move the decimal over 19 places to the right. Do you know how much rice that is? It would cover the earth 3 feet in rice. He'd have been the richest person in the world. It's a legend. I don't know if it really happened. Apparently he did it facetiously. Basically, he paid him a lot of money. And he did figure it out. He figured out density, the equation for density, by sticking his wife with it. He was getting mad. He was trying to figure it out, and his wife got mad at him and said, why don't you go take a bath? You got to take a break from the problem. He stuck his foot in the bathtub, and what happened to the water? It rose, and he figured out a way to calculate displacement, which is a way to calculate density. And then he was able to find the mass of the gold bar. But anyways, so he understood the power of exponential functions. He understands that if I'm doubling, if my money's doubling every day, like I'm going to be a millionaire quick. That's why it only takes 30 years. 30 years, if you invest $100 a month starting right now into a good mutual fund, which you can go find at any standard financial place. You could go right now. There's one in town. You put it in a pretty low risk, not even have to be high risk, something that gets like 8-10%. But you have to leave it in there for 30 years. In 30 years, you'll be a millionaire. If you keep, and you only have to put $100 a month for 16 years.
Is that better than a
So,
Roth IRA?
Roth only gets like 4 to 5%. Yeah, you have to put in a little bit of risk.
Not take it out though?
You can't take it out, because if you do, you surrender it and you have to pay taxes on it, and then there's penalties. But if you're willing to wait 30 years, and somebody are like, well, that means I'm going to be like 48 years old. Yes, you'll be Mr. Morris's age, and I'm still young. Okay, you still got a lot of life left, but you'd be a millionaire. But most people don't do it. Why? Because slow and steady wins the race, and nobody likes waiting that long. It's like trying to let your hair grow out, guys, after you shave your head. It's the most annoying thing on planet Earth. Okay, or girls, if you cut your hair off really short and then you want it to grow it back out, it feels like it's going to take forever. Like you're in that middle phase where you're like, oh, just grow out, you know, especially if you cut it really short, if you like chop it off. My daughter chopped her hair off one summer down to like to her shoulders, and she was like, no, I want it long again. And it just took forever. So, but my cross-country runners shaved their heads this past fall, and now Bjorn finally looks normal again. He looked a little weird for a while, just looked out of place. So you got to be patient. You got to be patient if you're going to invest that kind of money. But anyways, doubling. Now, if I do this way, now watch this. This is going to be a little weird for somebody because it sounds like Hofner didn't do this. If I do negative exponents, if I go 2 to the negative 1, that's one of my 5 fingers. My class will know this. I don't know if Knutson's or Hofner's. If you didn't cover it, then the last time you had it was with Mr. Hansen in 8th grade. Does anybody remember what you do with a negative exponent? My class should. Negative exponent, what do you do, Jack? Nope. What do you do, Maddie? You flip it. You do the reciprocal. So 2 to the negative 1 becomes 1 over 2 to the first power. And that's how it becomes positive when you flip it. Write that down, Garfunkel. So then we get 1/2. So let's go f of negative 2. If I do f of negative 2, I'm going to get 2 to the negative 2, which is going to be 1 over 2 squared, which is what? 1/4. I want you to look at this because there's a pattern. What do you think the next one's going to be? 1/8, because if you go f of negative 3, you're going to go 2 to the negative 3 power, which is 1 over 2 cubed, which is 1/8. Now look, when I went this way, what was I doing? Multiplying by 2. What's going to happen if you go the other way? Dividing by 2. Are you serious you're going to miss again next week? Where are you going? Divide by 2. Divide by 2. Divide by 2. Now, what is dividing by 2 the same thing as multiplying by? Talk to me. What is dividing by 2 the same thing as multiplying by? By multiplying by half or 0.5. So when you divide by 2, you're really multiplying. So this way you're multiplying by 2, but this way, multiplying by the reciprocal, you're multiplying by a half. So forwards, you'll be multiplying by the number itself, but if you go backwards, you're actually multiplying by the, everybody say it, you're multiplying by the what? So if you go forward multiplying by 2, you're going to go back dividing by 2, which is multiplying by 1/2. What if this would have been 3 to the x power? What would you do forward? Multiply by 3. What would you do in reverse? Divide by 3 or multiply by 1/3. What if it's 4 to the x? Multiply by 4 or divide by 4, which is multiplying by 1/4. What if it's 5 to the x? Multiplying by 5 forward, or in reverse, it'd be what? Times by 1/5 or divide by 5. Now, here's what this is going to look like. You ready? Here we go. First look at an asymptote. So we're going to plot all these points. So we're going to plot, we've already got 0, 1 plotted. So everybody got that down, 0, 1. Now we're going to go to 1, 2, 2, 4, and 3, 8. Plot those. So we're going to go 1, 2. What's the next one? 2, 4. 3, 8. And 3, 8. Now, let's pay attention. Hold on 1 second. Has everybody got that? Now, on the other side, watch what's going to happen. You're going to go negative 1, what? Half. So you're just going halfway up. Pay close attention here. Now, negative 2, what are you going to be at? Half of a half, which is a fourth. You're going to keep cutting it in half, that distance. What are you getting closer to? Huh? What did I put the third one at? Let's see. You mean this one? Oh, that's supposed to be at 4, isn't it? My fault. My bust. All right, sorry about that. Okay, is that better? All right, good catch. All right, what's happening each time I go back? You're halving it. Now it's half, which is an 8. What if I went to the next one? Let's just predict. What would the next one be? Even closer, a 16th. What would the next one be? 32nd. What would the next one be? Is it ever going to get to 0? That's an asymptote. When you never touch it, you just keep getting closer. So there's an asymptote at 0. So here's what we're going to write down. Ready? We're going to write down what all this means, and then we're going to try another example. You get your first J-curve. It's named after me. All right, your first J-curve. Looks like the letter J. Okay? All right, domain. You should remember this from last try. Does this graph go to the left forever? Does this graph go to the right forever? Does it cover everything from the left to right? So what is the domain? Double bar R. I don't know how Mr. Hawthorne did it. I don't know how Mr. Knudsen did it. We put double bar R. Some of you put negative infinity to infinity, but that's what double bar R means. You draw an R with 2 bars. So then you don't have to write negative infinity to infinity. Do you like double bar R, Dasa? Yeah. You do, because you're used to it. Range. Does this thing go up forever? Mm-hmm. Does it? Yeah. Does it go down forever? No. No. What does it go down towards? 0. It's going up forever. Does everybody agree? Yeah. It's going down, but what is it going down towards? 0. Will it ever get there? No. No. So what are you going to put? Parentheses 0, comma, infinity. Why do we not put a bracket at 0? Because it does not hit 0 ever. Or you could put this. Some people are like, can I just put y is greater than 0? That works too. Do you have to put both? Pick which way you like better and do it. All right, end behavior. You would have learned this last try. All right, x approaches infinity. Does anybody remember what that means? I call these the tails, T-A-I-L. Okay, that's how far we know. This means we're going to the right. Right here means you're going to the right. What I want to know is as you go to the right, what is the y doing? What is f of x doing? So if I go to the right, okay, let's go to the right. Garfunkel, what's y doing? It's going up. So what does it go up towards, everybody? Infinity. So that goes right here. It goes up to infinity. All right, let's go to the left tail. The left tail. What is the left tail doing? Everybody look over here. What's the left tail going towards? 0. It's going towards 0. It's not going down forever. It's going down towards what? 0. And people always get confused because they're like wanting to say negative infinity. Yes, I know x is going to negative infinity. You are correct. Thank you. Thank you for the obvious. I don't need to know that. I know x is going to negative infinity. My question is not what x is doing. It's what y is doing. Y is f of x. Okay? Y-intercept, where the graph crosses the y-axis. Can anybody tell me where the graph crosses the y-axis and where every one of these are going to cross the y-axis? 0, 1. So put 0, 1. Every one of them. And that's based on your value a, remember? That's what a equaled. And there was every one of these problems tonight is going to have a equal to 1. So everybody's going to have 0, 1. All right, the asymptote. What is the asymptote at? You're going to put y equals 0. It'll be y equals. Because it flattens out at 0. Now, the first time you see all that, it's kind of weird. Second time, it'll be okay. And then I'll have you practice a few this weekend. Okay? So let's try another one. That's pretty much it. I'm going to do it. After this, I'm going to do I'm going to do one more, and then I'm going to do an L curve and call it good. Okay? And then I'll answer any quick questions before we take the quiz after you get back from lunch. It's only 15 questions. And I made them pretty easy. And did anybody study? Who looked over the notes? Look over them at lunch. Okay, 3 to the x. 3 to the x. Where do all of these start at? Where do all these start at? 0, 1. So here's what you get to do now. You ready? I'm only going to make you do 3 points, and I'm going to let you cheat now. You look at the base. What's the base? That's how it grows. Are you ready to cheat? Who wants to have to do a table every time? Okay, I'm going to teach you how to cheat now. All right, the last one, it was a 2. Did you see that? Look at it. When you went to the right, okay, so it starts, and what's going to happen here, I got to get my pen. So it started at 1, okay, and then what's going to happen, the first point to the right has to be at what? 2. The first point to the left has to be at a what? Half. So when you do 3 to the x, the first point to the right has to be at what? 3, because it's 3 to the x, and then the first point to the left has to be at a third. So 3 to the right, a third to the left, because you're multiplying by 3 when you go to the right, and you're dividing by 3 when you go to the left. Now, if you wanted to do the next one, could you do it? You could take the 3, and if you went over one more, now what it would be? You would have to take 3 times what? Nope, you'd have to take 3 times what? 3, which is what? The next one would be at 9. And then here you would have to take a third times a third, which is 1/9. But we're just going to make look like it's close to 0 is all. So is there much difference between 3 to the x and 2 to the x? What is the difference? Would you rather your money double or triple? So what is it going to be the difference? J curve's going to be a little bit what? A little bit, not bigger, not wider, steeper. Be a little taller. It'll be a little bit more straight up and down. It goes up faster because you're tripling your money instead of doubling it. So if you compare it, after we draw this one, it's going to look a little steeper. Okay, so we're going to have, it's going to go up faster because it only went to 2 and 8, but this time it's up to 3 and 9 already. And it's going to go towards 0 a little faster, but does it matter? Because will I ever get to 0? Doesn't matter. You can drive as slow and fast as you want. You're never getting to 0. Never touch. You can't touch that electric fence, Chase. Now, technically, what I like to tell students to do, and you might want to get in the habit of this, you really don't need to do it tonight, but technically you should draw a dashed line on your electric fence, your asymptote, because eventually I'm going to change that next week. I'm going to move it. We're going to shift it up and down. Do y'all remember doing shifting, left, right, up and down? Last try with parabolas, when you had to take the parabola and shift it left, right, up and down. We're going to do that with the J-curves.
I remember doing that first try.
We did a little bit. Not much. All right, domain. Yeah, first try would be when we did more of it. All right, what's the domain? What's the domain for every J-curve? Just get it memorized, Aiden. What's the domain? Double bar R, every time. You don't even have to guess. You can just be like, Dawson can just be like, oh yeah, it's a J-curve, double R, every time. Why? Because it goes forever to the what? And it goes forever to the, some people are like, no, it's not, it's going up, Mr. Morris. But what is it doing as it goes up? It's sliding right. Okay, what's the range? The range will always be based on that asymptote. Is it above the asymptote or below it? Look at the graph. Is it above it or below it? Above. So it's going to be 0 to infinity, or y greater than 0. All right, what's the right tail do, Jack?
Goes up.
Up to infinity. Everybody, what's the left tail doing? 0. Which the left tail, by the way, is the asymptote. So if you want to go ahead and just say, oh yeah, that's the asymptotes at 0 then. The tail that's not infinity or negative infinity will be the asymptote. So the tail that approaches a number will be the asymptote. All right, what's the y-intercept? Everybody, where does every one of these tonight going to crawl? 0, 1. That's easy. All right, go to the next page. We're almost done. All right, now we're going to change it. I'm going to do number 4 just for kicks. Actually, I'll do number 3. I'll let you do number 4. We're going to change it. Okay, everybody look at the base. Listen up. Is the base bigger than 1 or less than 1? It is what? B equals 1/2. 1/2 is less than 1. So is it growth or decay? All right, it is not going to be a J-curve anymore. It's actually just as easy. All right. You ready? Watch how easy this is once you figure it out. Where do all these start? 0, 1. Everybody go to 1, 0, 1. Can anybody remind me why it starts at 0, 1? Because if I plug 0 in, what's anything to the 0 power? 1. That's why it starts at 1. Okay? Now, this is 1/2 to the x. So now when you go to the right, it's not multiplied by 2. It's actually what? It's actually cut in half. So when you go to the right, it's actually cut in half. So I go to the right, it's cut in half. So now it's at a half. If you go again, it'll be at a half of a half is a fourth. And then if you did half of a fourth, you'd get a eighth. And you could keep going.
So every time you get a fraction, is it just going to go down?
Now it's going to go down instead of go up. So instead of a J curve, it's going to be a L curve. It's going to be an L curve. Now, when I went to the right, I cut it in half each time. When I go to the left, I got to do the reciprocal. What's the reciprocal of a half? What is it? 2. So it's going to be at 2 at the first one. And then it would be at the next one, it would be at what? 4. And what would it be after that? 8. And then 16, and then 32, and it just doubles. It keeps doubling to the left. So now it's just reversed is all. Does that make sense? So what kind of curve do we have now? L curve. La, 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 la. Not much of a singer. I like to sing, but I can't sing very well. All right, I'm going to call on people just whoever I feel like. Kaya, what's the domain? Look at it. Does it go the right forever?
Yes.
Does it go the left forever? What's the domain? Double bar R. What did I just say a minute ago all the domains are going to be for J curves? So what do you think they're going to be for L curves? J curves and L curves, the domains, all real numbers. Okay? All right. Nora, what's the range? Let me ask you this. Does it go up forever? It does go up forever. Does it go down forever? What does it go down towards? 0. So what's the range? Y is greater than 0, or you can go 0 to infinity. Dasa. Don't whine. You're going for a week. Please say you're not going for a week.
What?
You're not going for a week again, are you?
Wednesday, Thursday, Friday, Monday, Tuesday, Wednesday.
Where are you going?
Whistler in Canada
For what?
for skiing.
Golly. Okay. All right. Dasa. We go to the right. What is the right tail approaching? 0. Very good. You're going to have a lot of videos to watch on your own. What is the left tail approaching? What is the left tail approaching, everybody? Infinity. Very good. What's the y-intercept for every problem? 0, 1. What's the asymptote? Y equals 0. Is this easy? Okay.
For every problem, like literally anything. You
Until Monday, every problem, the asymptote's going to be at 0.
no, I mean the y-intercept will always be.
At 1 until Monday. Now, one more and then we'll go to lunch. Okay, you try 2 to the third, 2/3 to the x power. Go. You try this one on your own. Right now, with the person next to you, that's fine. Try it. It's 2/3 though. 2/3 to the x. Is it going to be a J curve or an L curve?
Would it go from 2 to the 3rd to 4 to the 9th?
Nope, you cannot ask a question. Because I want you to try it.
But I wanted to make sense.
You will in a second. Try it.
Yeah.
Come on, think about it.
I got something.
You just be squaring it. Like you keep timesing, so you start at 2 to the 3rd, and then like you times it by itself.
Yes.
So then before the 9th.
So
Yes.
times by the left, on the left.
Reciprocal.
Oh, yeah.
Is Cash here? Jackson here? Yes. Anastasia here. Kelsey's here. Nora's here. Charlie's here. Who? Nora is, though, the other Nora. Ty's here. Rowan's here. Caleb's here. Is Caleb Schultz here?
I don't know how to do that.
Yeah, Caleb's here. Simon's not here. Alex is here. Kaya's here. Brock is here. Caleb Meeks is here. Maddie's here. Jamie's here. Jack, Jacob, Jingle, Hyder Smith, Jocelyn, Brooklyn, Drake, Chloe, Dasa, William, Anaya, and Chase. All right, who thinks they have it? All right, first of all, let's decide 2/3. Is that bigger than 1 or smaller than 1? Good gravy, people. It's a fraction. If the numerator is smaller than the denominator, it is definitely smaller than 1. I'm going to say that again. If the numerator is smaller than the denominator, it is definitely between 0 and 1. It's a fraction between 0 and 1. The only time the fraction's bigger than 1 is when the numerator is bigger. Okay, so definitely smaller. All right, so it's decay. So we already know it's going to be an L curve. So I'm going to start at 0, 1, and then when I go to the right, I'm going to go to 2/3. And then I'd be 2/3 of that, which would be like 4/9. And then it's just going to steadily go down. It doesn't matter as long as you know that it's approaching 0 on that side. I just need you to really get 1 point right. Make sure you get 1 point to the right and 1 point to the left, and then after that, just get a general sketch. So when I go to the left, though, I need to do the reciprocal of 2/3. What's the reciprocal of 2/3? 3/2. So where am I going to put 3/2 at? 1.5. So this one is not going to be as steep. And then if I went 3/2, what's 3/2 times 3/2? 9/4. Where's 9/4 going to be? 2.25-ish. Is that right? About right there? So it's going to be an L curve. It's just a slow growing L curve. And it's not decaying as fast. It's an L curve. It's just a little lazy L curve. All right, real quick, then we'll go to lunch. What's the domain? Everybody, what's the domain? What is the range? 0 to infinity. What is the right tail? 0. Very good. What's the left tail? Infinity. What's the y-intercept? What's the asymptote? So we got about 2-3 minutes. You can look over your notes for a minute.